Alright, so hopefully the second half of 5.1 is really much quicker than the first half. So this, again, this is still section 5.1, and this is the same grouping of questions as the last few problems that I did. It's asking the same questions. The only difference between the problems I'm going to do right now and the problems on the last video is that these aren't factored. To find the x-intercepts, I'm going to take the function and set it equal to 0. And because of the exponent, I have to factor. This factors into x plus 1 times x minus 7. You'll notice that each of the factors has an exponent of 1 that's implied, or has no exponent shown, so there's a 1 implied. So the multiplicity of each is going to be odd. And let me just get the x-intercepts real quickly by taking the factors and setting them equal to 0. So for the x plus 1, you minus 1 from both sides, and you get negative 1. For the x minus 7, you add 7 to both sides, and you get x equal to 7. So that gives me x-intercepts of negative 1 comma 0, and that has odd multiplicity because the parentheses that the 0 came from, or the intercept came from, has an exponent of 1, which is an odd number. And the other intercept, x-intercept, is going to be 7, 0. That also has odd multiplicity. So at both of the intercepts, the graph is going to cross the x-axis as opposed to just touch. Nicely for parts C and D, there's no extra algebra to do. The leading coefficient, or the leading term, the term with the highest exponent, will clue me into the answers here. So because this is a second degree polynomial, the maximum number of turning points I could have is 1 less than 2, which is 1. And this function will look something like the generic parabola f of x equals x squared. And this graph is going to be a parabola once we get to it. And I could do some work and find the vertex, and I will have to because that's going to be a turning point. But I use my calculator to do that. So that's the beginnings of number 14. I'm going to sketch a graph. So it's x squared minus 6x minus 7 for the function. I think just a generic standard window should work for this. So my y equals, clear it out and do x squared minus 6x minus 7. I don't know why. There's spots where you just can't see this. And then hit my zoom and standard. So it's just a parabola that opens up. I don't see the bottom of, I don't see the whole vertex. So I'm going to expand my window by making the y's go lower. I'm going to change my y min to a lower number. My y min was at negative 10. I think if I make it to negative 20, I'll probably see the whole vertex of the parabola. Everything else I'm leaving intact. So I can make a reasonable graph. The x-intercept at negative 1 and the x-intercept at 7 show up there. And the local minimum point I'm going to get by going second, calc, going down to option 3 that says minimum, tracing till I get close to the vertex but to the left of it, and then get on the other side of the right side of the vertex and trace and hit enter, get as close as you can to the vertex and hit enter, and I'm going to round this 2.999 to 3. I'm going to say it's 3 negative 16. So I'm going to take this for my graph. I know that it has an x-intercept at negative 1, at positive 7. Looks, something like this. And the minimum or turning point is the vertex at 3 negative 16. That's a reasonable graph, as nice as you need to do. The end behavior, on both sides it goes up, so I'm going to say it rises to the left and rises to the right. For the increasing and decreasing, This half of the graph is the decreasing. And I'm going to say it's decreasing from the far left edge of the x-axis, which is negative infinity, to the x-coordinate of the vertex, which is 3. And then after the vertex, it turns around and starts going up. This region here, the graph is going up, or increasing. And in terms of x, the x-coordinate of the vertex where it starts increasing is 3, and it increases forever to infinity. That's all there is to do for that problem. Next problem is probably slightly more complicated, but hopefully not horrible. No, it's not really even significantly more complicated other than nothing. The factoring is even easier. So for part A, finding the x-intercept, I take the function, set it equal to 0. I can solve by factoring, or I can solve by square roots. It's easy enough for me to factor this, so I'll solve it by factoring. Once I have it factored, I can set the factors equal to 0. The left factor, I subtract 3 from both sides and get negative 3. The right factor, I add 3 to both sides and get x equal to 3. So my x-intercepts are going to be the point negative 3, 0, positive 3, 0. They both have odd multiplicity because neither of the factors has an exponent, so there's an implied 1. Which means at each intercept, at the negative 3, 0, as well as the 3, 0, the graph is going to cross as opposed to just touch the x-axis. This is a second degree polynomial, so you can only have at most one turning point. And for big values of x, the graph will look like x squared. The minus 9, if you make a winding up window, that won't really show up so much. That'll get diluted as the window gets bigger. I'm going to sketch a graph. Y equals clear x squared minus 9. Hit my graph button. I have that same window. It seems to work fine. There's an x-intercept at negative 3 where the graph crosses the x-axis. There's an x-intercept at 3 where the graph crosses the x-axis. That's going to be the point 0, negative 9. I'll find it by going second calc, minimum, trace to the left of that point, hit enter, trace to the right of that point, and hit enter, and trace close to that point, and hit enter, and it tells me that it's 0, negative 9. So I'm going to transfer this along with the intercepts, put it on a graph. If I actually save that part. So the graph looks more or less like this. At negative 3, 0 and at positive 3, 0, the graph crosses the x-axis. It has that minimum or vertex at 0, negative 9. So I have x-intercepts would have nothing in this case to do with increasing and decreasing. It's everything, so I sketched a graph. I approximate the turning point. I labeled the x-intercepts. This graph, again, is rising on both sides of the y-axis. So I'm going to say it rises to the left. I'm being lazy and just saying rises left and rises right. And just like the last graph, this is decreasing from the far left edge of the graph to the 0 or the minimum. So it's going to be decreasing from negative infinity to 0. And then after the vertex, the graph starts going up, and it increases with the up arrow from 0 to forever to infinity. Always round brackets on the increasing and decreasing. All right, so these problems should go fast, and the homework might not take that long. It's just a matter of getting through the understanding of the concepts, because there are a lot of concepts that you might have not been familiar with. Finding the x-intercept here, I take the function, set it equal to 0. Need this x here. Need to factor. I'm going to pull out a common factor of 2x. When I factor that out, I have a 3x squared minus 2x minus 5 equal to 0. That's harder factoring, so just in case you can't do it, I'm going to factor this 3x squared minus 2x minus 5 using bottoms up. I'll multiply this 3 and that 5. Get x squared minus 2x minus 15. This factors into x plus 3 times x minus 5. I started off multiplying by 3. I'm going to divide by 3. First 3 divide out and I get x plus 1. Second 3, I bring the 3 up and get 3x minus 5. So this 3x squared minus 2x minus 5, I needed to factor it. I could factor it in my head. We haven't factored using bottoms up for a while, so that's how that's going to factor. So I'm going to change this to 2x times x plus 1 times 3x minus 5 equal to 0. All the multiplicities are going to be odd because none of the factors have exponents. So I'm going to find my x-intercepts by taking each of the factors, setting them equal to 0. For the factor of 2x equal to 0, I'm going to divide by 2 and get x equal to 0. That's going to give me an x-intercept at 0, 0. Again, that factor didn't have an exponent, so there's an implied 1. It has odd multiplicity. For the x plus 1, I minus 1 and get x equal negative 1, or the point negative 1, 0 for an x-intercept. That also has odd multiplicity. When I set the 3x minus 5 equal to 0, I add 5 and get 3x equal to 5, and then divide by 3 and get x equals to 5/3. And that's also going to have odd multiplicity. So I have 3 x-intercepts, and for each x-intercept, because none of them have an even exponent, the graph is going to cross the x-axis as opposed to touch. It's a third degree polynomial, so I have a maximum of 1 less than 3 or 2 turning points. And for really big values, zoom the window out, the graph of 6x cubed and the graph of my function are going to look remarkably similar. Now I'm going to sketch a graph. Y equals 6x up arrow 3 minus 4x squared minus 10x. I'm going to do a zoom standard. That window probably won't be adequate, but maybe it is. Oh, it probably is. So it's just a nice little S-shaped figure. So I'm going to copy this graph. So this is the negative 1, 0. There's a 0, 0. There's a 5/3 0. If I want to, I could crunch the x's and make the x's go smaller. It might make it easier to see the intercepts. Let me change the x's to the 5s as opposed to leaving them at the 10s. And doing that is just going to make it easier to see the intercepts. There's the intercept at negative 1, 0. There's the 0, 0. There's the 5/3 0. I need to find that point and that point. Let me do one before I flip this page. I'm going to find that maximum by going second calc, maximum, trace, so my cursor's to the left of that maximum, hit enter, trace to the right of that maximum, hit enter, get as close as I can to that maximum and hit enter, and it tells me it's at negative 0.55, 3.29. So I'm going to copy this graph, throw the intercepts on, that point on, then I'll find the minimum. So this graph, more or less, it goes through the point negative 1, 0, 0, 0. 5/3 0 is 2 1/3, 2 2/3 0, so 5/3 0 is just close to the 2. Has this maximum at negative 0.55, 3.2, so maybe about, call that negative 0.55, it's actually 3.29. I'm just rounding to 2 decimals just so I'm consistent. So the portion of the graph that I have so far almost have everything labeled. The only thing left I have to label is that turning point. That's the minimum value. So I go second calc, go down to minimum, trace with my right arrow to get close to that minimum point, but to the left of it, and hit enter. Trace around, enter, and then as close as I can to the minimum and hit enter. And I'm going to round that to 1 and -8. So I'm going to say for this last point right here, I'm going to say that's the point 1, -8. For the end behavior, to the left of the axis, it's going down to the left of the y-axis, so let's say it falls to the left, and to the right of the y-axis, the right end goes up, so I'm going to say it rises to the right. Now for the increasing and decreasing, this first region right here, from the far left edge of the graph to the first turning point, the graph is increasing. And in that region, I'm going to say is the region from -infinity to -0.55. And then after I get to the turning point, or the maximum, the graph goes down. It goes down from the high point to the low point. That's a decreasing interval. It's the only decreasing interval. And in terms of x, that's decreasing from -0.55 to +1. And then after the last turning point, it goes up forever, it increases forever. That's from the 1 to infinity. So I always do increasing and decreasing in terms of x coordinates. So that's everything I needed for that problem 18. Getting close to being done with these kinds of problems. 20, to find the x-intercepts I need to factor. I'm going to set the equation equal to 0. I'm going to pull out a common factor of 2x squared. When I pull out a 2x squared, I'm left with an x squared minus 9. The x squared minus 9 I can factor to x plus 3 times x minus 3. So this is completely factored. Now I'm going to take each factor and set it equal to 0. Setting the 2x squared equal to 0, there's a square that's going to be an even multiplicity. So it's going to touch whatever this equals to. I divide by 2, I get x squared equal to 0. And this just happens at 0 because x squared equal to 0 is the same thing as saying x times x equals to 0. And that tells me that x equals 0, and it actually has an even multiplicity. So the first x-intercept from the 2x squared equal to 0, it's going to be 0, 0. It's going to have an even multiplicity because of the x squared. That gave me that one answer of 0. And at 0, 0, the graph is going to touch as opposed to cross the x-axis. The other x-intercepts are going to have odd multiplicity because the other factors don't have exponents. For the x plus 3, I'm going to subtract 3 and get -3. That's going to give me an x-intercept at -3, 0. That has an odd multiplicity, and at that -3, 0, the graph is going to cross the x-axis. For the x minus 3, I'm going to add 3 to both sides, get x equal 3, which is going to give me an x-intercept of 3, 0. That came from a problem with a odd exponent, so that's also going to be the case where the graph crosses. So this is a 4th degree polynomial, so I could have at most 3 turning points. There's always one less than the highest exponent when it's multiplied out. And if I zoom my window out, graph both the function given and the function 2x to the 4th, the graphs will look similar. Let me graph these. Hopefully I can see the 3 intercepts and find my turning points. So y equals clear and 2x up arrow 4th minus 18x squared. Hit my graph button. This window might not be good. It's definitely not good. It's not so bad. I saw the x's at the -5s. It's not that bad. It needs to go down lower to see the the minimums. I'm going to hit my window button and make my Y min get down lower. It looked like I was far away from the min. I'm going to go down to minus 30 on the Y min as opposed to maybe minus 20, which might have been my first guess, just to hope I see the bottoms. And still didn't make it far enough. I got a lot closer, but maybe minus 40 will do it. I think minus 40 would do it. I'm going to be safe and put minus 50. There isn't a right and a wrong window, just as long as you can see the features of the graph that you're asked to describe, that'll be fine. So this is a reasonable graph. If I want to make the Y max go higher, just, maybe just so I can see the graph a little bit better below and above the x-axis, that's fine. The nice thing about this graph is actually symmetric to the y-axis. These 2 points are going to be the same, except the x is going to have different signs. I'm going to find both of them real quickly. I do second calc minimum. For this one over here, best I can get my cursor moving to the left of that low point and hit enter. Then go around, get my cursor going to the right of that low point and enter, then get on the end. That tells me that one of my points is negative 2.12, negative 40.5. I'm going to do the other one. I'm virtually guaranteed I'm going to get positive 2.12, negative 40.5 when I do second calc minimum again and go all the way to the other low point. That turning point that I'm passing right now is 0, 0. I don't need my calculator to help me find that. I can just tell by looking at it. So for this one, I'm expecting the exact same y, which is an x with a different sign. So 2.12 and negative 40.5 are my turning points, or minimum points. So let me make a copy of that graph. So I have x-intercepts at negative 3, and positive 3 and 0. At 0 it touches, at the 3s it crosses. So when I go to sketch this graph, I need to see the point negative 3, 0, positive 0, 0, positive 3, 0, and then these low points at negative 2.12, negative 40.5, and positive 2.12, positive 40.5. And now I'm just going to copy that more or less. So it goes. So something like that. Oh, again, my graph's not perfect. I mean, these humps are supposed to look identical. Mine don't look identical, but it's way more than close enough. I have everything labeled that I want to. Crossing the x-intercepts at the 3s, touching at the 0s. I see the minimum points or the turning points. Now I'm going to describe the end behavior. On both sides it's going up, so I'm going to say it rises to the left and rises to the right. And then for the increasing and decreasing, the first bit of the graph is decreasing, and in terms of x, it's decreasing from x equal negative infinity to the x coordinate of that turning point of negative 2.12. And then once it gets to that turning point here, it starts moving its way up and it increases. And the region, the interval there that it's increasing is from negative 2.12 to 0. And then at the turning point, at the 0, 0 turning point, it starts going back down. And the region it's decreasing there is from 0 to 2.12. And lastly, from 2.12 forever on, it's increasing again. Notice I'm only picking off the x's for increasing and decreasing. So that's everything I needed for this. Again, there's not a heck of a lot of algebra for any of these problems. The algebra at the end is the factoring for the end problems. The beginning problems had less algebra, but uglier graphs. When I give you something that needs to be factored, it's, I don't know, the graphs are just easier to get windows for whatever reason. It just kind of works out that way. 22 might be the last one of these graphing problems, and then we get into a new style of problem, which isn't terribly horrible, but it's different. So finding the x-intercepts for 22, I take the function itself, set it equal to 0. I'm going to solve it by factoring again. I'm going to pull out my common factor of 2x squared. Feels so much like a problem that I did just a bit ago. Oh yeah, so if you look at this problem, 18 and 22, the only difference between 18 and 22 in the equation is instead of having common factor of 2x, there's a common factor of 2x squared. Amazingly, when I get to the graph of 22, if I compare it to the graph of 18, that subtle difference, that extra x, is going to make a big difference in the graph. So I'm going to solve this by factoring. Pull out my common factor of, instead of 2x like in 18, 2x squared. When I pull that 2x squared out, I'm going to be left with a 3x squared minus 2x minus 5. And that's a really nice thing because I know how to factor that. I just factored 3x squared minus 2x minus 5. I'm going to steal that x plus 1 times 3x minus 5 that I knew it was. So this is going to give me 2x squared times x plus 1 times 3x minus 5 equals to 0. I'll set the 2x squared equal to 0. For that, you divide by 2. You get x squared equal to 0. That's really x times x equal to 0. The only answer that works for that is x equal to 0. And that gives me an x-intercept of 0, 0. That has an even multiplicity. And so at 0, 0, the graph is going to touch and not cross the x-axis. For the factor of x plus 1, when you set it equal to 0, you subtract 1 and you get negative 1. The x-intercept that comes from it is negative 1, 0, which has odd multiplicity. And so at negative 1, 0, the graph is going to cross the x-axis. When I set the 3x minus 5 equal to 0, I add 5 to both sides and get 3x equal to 5. Then divide both sides by 3 and get x equal to 5/3. That x-intercept that gives is the intercept 5/3, 0, or 2 2/3, 0. It also has odd multiplicity, so at the 5/3, 0, the graph is going to cross the x-axis. This is a 4th degree polynomial. The maximum number of turning points is 3. And if I made a big enough window, the graph of just plain ordinary 6x to the 4th and my function will look very similar in their graphs. So now I'm going to graph this function, and with it in mind, when I did problem 18, that is almost the same with just an extra x. I had that. Just wondering how that's going to impact the graph. So when I hit my y equals, clear this out, do 6x up arrow 4 minus 4x up arrow 3 minus 10x squared, and hit my graph button. I don't know what window I have, and it's maybe not the best window because it doesn't focus in enough on the origin. I can't tell so much here. Really need to crunch down my y's quite a bit. So I'm going to change my y's because they were at the 50s. I'm going to change my y's back to the 10s. I think leaving the x's at the 5s wasn't a bad thing. I think I saw everything I needed to left and right. It just I didn't go low enough, or was going way too low. So that's beautiful. So the graph that I had was this, and then I get that, and all of a sudden the end behavior is different. What it does at the origin is different. Let me find this minimum before I flip this page. So I'm going to go second, calc, minimum, and trace to the left of the low point, to the right of the low point, and then close to the low point. So one of the points I'm going to type is negative, I'll say 0.70, negative 2.09. So I'm going to copy this graph along with the 0, 0, negative 1, 0, and 5/3 0 into my spot where I'm going to put the graph. So this graph has an x-intercept at -1, 0, an x-intercept at 0, 0, an x-intercept at 5/3, 0, which is 2 2/3, 0, and I know this low point is at -0.70, comma, -2.09. So I've got this much of the graph kind of known from here to here. It drops down and comes back up. I want to get this point now. To get that point, I go second calc. That's another minimum point. Get my tracer going. Enter, trace to the right. Enter and get close to it. Enter. And this looks to be the point 1.20, comma, -8.87. So that's a reasonable graph. It's maybe, again, it's not awesome, but it's certainly good enough. When you take calculus, you'll learn how to not use your calculator to get the graph, just to use calculator. I mean, just to use calculus, which will be tough. But it's something you do a lot in calculus. For the end behavior, on both sides it's going up. So I'm going to say it rises to the left and rises to the right. And now for the increasing and decreasing. This first region, it's decreasing, and that's the region from the far left edge of the x-axis, which is -infinity, to the x-coordinate of that minimum point, or that turning point, which is -0.70. And then, between that low point and that high point, it's increasing. To define that as an interval, I'm going to say it's the region between, the interval between -0.70 and 0. So, and now between the high point and the low point, the graph is decreasing again. That region I'm going to say is between 0 and 1.20. And then in the last region, after the last turning point, from x equal to 1.20 all the way to x equal infinity, the graph is going to be increasing again. And so look, I'm using arrows for the increasing and decreasing. The down arrow means decreasing, the up arrow means increasing, and that's very common to show arrows rather than writing the words. So finally, done with that style of problem. There were only 11 problems, but it took me 2.5 hours to do those 11 problems, which means I can't put too many of them on a test. The next kind of problems, it says, find a polynomial that has these x-intercepts. Very easy problem other than a little bit of grungy algebra. So very specifically, it says I want a polynomial of third degree, which means it has an x cubed in it, or possibly a 3x cubed, or a 10x cubed, or a -4x cubed. But I want a polynomial that has x-intercepts of x equal -2, x equal to 4, and x equal to 6. Notice I didn't write -2, 0, 4, 0, 6, 0. It's not uncommon to see x-intercepts written just as numbers and call them x-intercepts. To get the polynomial that I'm looking for, I'm going to take each one of these equations and set it equal to 0. For this one, I'm going to add 2 to both sides and get x plus 2 equal to 0. For this one, I'm going to minus 4 from both sides and get x minus 4 equal to 0. For this one, I'm going to subtract 6 from both sides and get x equal to -6. I claim if I multiply those three, the x plus 2, the x minus 4, and the x minus 6, that's a function that's going to have x-intercepts of -2, 4, and 6. It's going to cross the x-axis at each of the x-intercept. My instructions say multiply out your polynomial. That's the grunge part of this. Let me do the first multiplication. The first multiplication is I'm going to multiply the first two parentheses, leave the x minus 6 alone. In the first two parentheses, I'm going to do the firsts, x times x is x squared. The outers, x times -4 is -4x. The inners are 2x, the last are -8. So I can combine the outers and the inners, and I get x squared minus 2x minus 8 times x minus 6. And I'm going to multiply this out. I'm going to go x squared times x. X squared times x is x cubed. And then x squared times -6 and get -6x squared. and then minus 2x times x and get minus 2x squared, and then minus 2x times minus 6 and get plus 12x, and then minus 8 times x and get minus 8x, and then minus 8 times minus 6 and get plus 48. Combine like terms, that'll be my answer. So my answer to this problem, the polynomial that has a third degree, that has x-intercepts of -2, 4, and 6, is going to be x cubed for that term. These two terms with the x squareds both have minuses in front of them. Those will combine to a minus 8x squared. 12x minus 8x is a positive 4x. Claim that's my answer. Easy to check my answer. I'm just going to graph the function and make sure it crosses and not touches the x-axis at -2, 4, and 6. So I'm going to take this polynomial that I came up with, which is y equals x up arrow 3 minus 8x squared plus 4x plus 48. So I'm going to take that function that I say is the right answer. It's a third degree polynomial. As long as it has x-intercepts of -2, 4, and 6, I'm okay. I'm going to hit my zoom button, go down to standard to get back to a regular window. Look at -2. There's the x-intercept at -2. That's at 4 and that's at 6. The graph crosses in each of the three places. I'm not asked to find the turning points. I've just created a polynomial, crosses the x-axis at -2, positive 4, and positive 6, and that's all the problem wanted me to do. So that's all there was to do for 24. In fact, that's all there's going to be to do for any of these problems, and the algebra can get slightly more complicated, but not much worse. So 26 wants me to have a degree 3 again. It wants me to have it cross the x-axis at x equal -2, at x equal to 4, and at x equal to 2/3. For the x equal to -2, I'm going to set it equal to 0 by adding 2 to both sides. For the x equal to 4, I'm going to minus 4 from both sides. For the x equal to 2/3, first I'm going to multiply both sides by 3. When you multiply the left side by 3, you get 3x. When you multiply the right side by 3, the 3's cancel and you get a 2. I'm going to subtract 2 from both sides and get 3x minus 2 equal to 0. The function that I'm going to look for is found by taking the factor x plus 2 times x minus 4 times 3x minus 2. It's going to be a third degree polynomial. The highest exponent is going to be a 3. And it's going to cross the x-axis at -2, positive 4, and positive 2/3. I'm going to multiply out the first two parentheses by foiling. Multiply the first, x times x is x squared. The outers, x times minus 4 is minus 4x. The inners, 2 times x is plus 2x. The last 2 times minus 4 is minus 8. I'm going to combine the outers and the inners and get f of x equals to x squared. Those combine to be minus 2x. So of the minus 8. Now I'm going to finish up. First thing I'm going to do is multiply x squared times 3x. That's going to give me a 3x cubed. Then I'm going to multiply x squared times a minus 2. That'll give me a minus 2x squared. Now I'll start with the minus 2x. I'll go minus 2x times 3x. That's going to be a minus 6x squared. I'll do minus 2x times minus 2. That'll give me a plus 4x. And then minus 8 times 3x is a minus 24x. And then minus 8 times minus 2, that's a plus 16. Almost ready to write my answer. I'm getting a third degree polynomial because the highest exponent is 3. The leading term is 3x cubed. These terms combine to be a minus 8x squared. These terms combine to be a minus 20x. And the plus 16 hangs around. So let me graph this to make sure I'm correct. I should have a function that crosses the x-axis and not touches the x-axis at -2, +4, and at 2/3, which I won't be able to say perfectly, but that would be just to the left of 1. So I'm going to graph 3x cubed minus 8x squared, so y equals clear 3x up arrow cubed minus 8x squared minus 20x plus 16. Hit my graph button, and there's -2 crosses. There's 2/3, I guess, is just the left of 1, and there's 4. Again, I don't need to expand my window to see the maximum points and minimum points or the turning points. And I didn't even need to graph it. But the graphing confirmed that I was correct because the graph crossed the x-axis at the x-intercepts, and that's all that I'm looking for this to do. 28's only wants a second degree, so it wants a parabola, and it wants at x equal to 3/4 and x equal to -1/2, it wants x-intercepts. For the x equal to 3/4, I multiply both sides by 4, which gives me 4x equals to 3. I subtract 3 from both sides, and I get 4x minus 3 equal to 0. For the x equal to 1/2, I multiply both sides by 2. 2's cancel on this side, gives me 2x equal to -1. I add 1 to both sides, it gives me 2x plus 1 equal to 0. The polynomial of degree 2, which means it's going to have an x squared for its highest exponent, can be found by foiling this out. So I'll foil this out. First, 4x times 2x is 8x squared. Last, outers, 4x times 1 is a positive 4x. Inners, minus 3 times 2x minus 6x. Lasts are minus 3. So I claim that this polynomial, 8x squared, and then I'm going to combine those together to be a minus 2x and bring down the minus 3. I claim that's definitely a second degree polynomial because its highest exponent is 2. I claim that it's going to cross the x-axis at positive 3/4 and at -1/2. I'm going to crunch my x's and my windows down to like maybe the 3's, just so when I graph this, it's easier to see 3/4 and 1/2. At the 10's, it's harder to see the fractions. So I'm going to go 8x squared minus 2x minus 3. So again, I changed my x's on my window just to make it so it's probably going to be easier to see the intercepts. So now 8x squared minus 2x minus 3. Had my windows going from -3 to 3 just so I can see the 3/4 and the -1/2. That to me looks like it's right halfway between 0 and -1. That's the -1/2. And that is between 0 and 1. I'm guessing it's 3/4 of the way. So I think that's properly 3/4 and -1/2 for my x-intercepts. Square root. The square roots are, I don't know. They're not that much worse. So I want x-intercepts at x equal positive square root of 3 and at x equal negative square root of 3. I'm not going to square those like I could do, because if I square those, I'm going to get too high of an exponent. I'm just going to set these equal to 0. I'm going to go x minus square root of 3 equal to 0, and x plus the square root of 3 equal to 0. The function I'm going to find is going to have x minus square root of 3 times x plus square root of 3 multiplied out. I'm going to FOIL this. My firsts are x times x, which are x squared. The outers are x times the square root of 3. That's a positive square root of 3 times x. The inners are minus square root of 3 times x. That's a minus square root of 3 times x. And the last are a minus square root of 3 times a positive square root of 3. That's a minus square root of 9. The outers and the inners cancel, and the square root of 9 turns into a 3. So the function that's going to have x-intercepts at plus and minus the square root of 3 is f of x equals x squared minus 3. It's degree 2 like I wanted, which is nice. And it should cross the x-axis at the square root of 3, but I need to know what the square root of 3 is in terms of having an idea of where the graph should cross the x-axis. Square root of 3 is 1.73. When I graph this, the graph should cross the x-axis at positive and negative 1.73. So if I go y equals clear x squared minus 3, hit my graph, and this is supposed to be at 1.73 and at negative 1.73. That's somewhere between 1 and 2 or negative 1 and negative 2. That looks close enough to me. I believe that I'm correct. And I don't have to graph this. The answer is enough by itself. But it's not that hard to sketch a graph to make sure your graph has the x-intercepts that you're looking for. (32), finally, last problem in this section. I want a degree 3, and I want x equal to square root of 3, x equal to minus square root of 3, x equal to minus 4. I'm going to write this one as x minus the square root of 3 equal to 0. This as x plus the square root of 3 equal to 0. This as x plus 4 equal to 0. Multiply them out, I get f of x is x minus square root of 3 times x plus square root of 3 times x plus 4. This multiplying, that's what I just did in problem 30. I don't need to FOIL it again. I've already FOILed that. I know that it comes out to be x squared minus 3. And I'm not going to reinvent that multiplication. That multiplication of those two things that just was what I needed to do. They multiply out. I could do exactly those steps again. They're not going to be different the second time through because I didn't make a mistake. So that multiplication, the first two parentheses come out to be x squared minus 3. And now I'm going to finish it up. I'm going to go x squared times x and get an x cubed. And then x squared times 4 and get a plus 4x squared. And then a minus 3 times x and get a minus 3x. And then a minus 3 times 4 and get a minus 12. There aren't any like terms there. That graph should cross the x-axis at 1.73, negative 1.73, and negative 4. It's a degree 3 that I wanted, and let me make sure that it actually works. So it doesn't take that long to check it. So y equals clear x up arrow cubed plus 4x squared minus 3x minus 12. And hit my graph button. Hopefully it crosses the x-axis at, well, it definitely crosses at the 1.73s. I don't see the negative 4 because my window's not big enough. Let me just tweak my window a little bit bigger. Make my x min maybe go to negative 5 just so I can see the negative 4. So if I count, there's 1, 2, 3. There's a negative 4. That's the negative 1.73, which is a negative square root of 3. That's the positive 1.73, which is a positive square root of 3. So that's everything I needed. The only thing I needed is the thing box, the function that is a third degree polynomial that has the proper x-intercepts. But the checking is so easy because I can mindlessly press buttons on my calculator that it's worth doing to make sure I haven't made a mistake. So finally, that's the end of section 3.1. Section 3.2 is also a longish section. 3.3 and 3.4, they could be made into one long section, so I broke them into two sections. And actually, it might be 3.4 and 3.5 that are that way. But there shouldn't be anything that's this long. 3.2 should probably be the next longest section, but it shouldn't be near as long.